Hey everybody. So today we talk about inheritance. Inheritance is the other arrow that we're going to use in our UML diagrams. And we kind of previewed it a little bit last week when we did graphical user interfaces, because the components that we defined made heavy use of inheritance. So at the end of this, I'm going to go back and we'll take another look at those class diagrams to see what they mean. So if you take a look at the guide, we start with just a little discussion of just like with association, inheritance is supposed to kind of hook up with the way that we think about the world. So in my example here, think about an ordinary human concept, a bird. You know, we all have a concept of a bird. They're all more or less the same concepts. They have the same kind of content. One thing you can say about a bird is that it's made up of other objects. So a bird has a beak. That's an association relationship. If you were going to model that in a object-oriented program, you might have a beak class and a bird class and an open-headed arrow between them, showing that every bird has one beak. A bird also is an animal. So this is a different relationship. This is the is-a relationship. And this in computer science, we call this an inheritance relationship. So we have another concept, animal, and the bird is an example of that. So we can say it's a subclass of animals. So animals are a class of objects in the world. Some things are animals and some things are not. And the bird is a subclass of that. Sometimes we also refer to these as parent and child. So the animal is the parent class, and below that is bird. And as a subclass of as a subclass of animal, the concept bird or a bird inherits all or most of the animal properties, or at least that's the default relationship. So one thing we know about animals is that they have to eat, they have to breathe. If I tell you a bird is an animal, even if you've never heard of birds before, you automatically know, yeah, they probably eat and they probably breathe, because I'm telling you that they're animals. So they inherit those properties from belonging to that class of animal. Okay, so the property of eating is inherited. And this is a powerful tool. It's a powerful tool in our thinking as well. So here's an example, a wug. This is not something that actually exists, but let's say I told you that scientists have discovered a new kind of bird called a wug. You immediately know a lot of stuff about the wug, or at least you think you do, because I told you it's a bird. And birds have a bunch of properties attached to them, like they have feathers, they have beaks, they can fly, etc. Now, of course, not all birds can fly, but that's the default. So if I tell you a wug is a bird, it automatically, you kind of download all those properties into the wug. You may not know exactly what it looks like, but you have a pretty good idea of what kind of a thing it is. Similarly, because birds are animals, you know that the wug eats and breathes and, probably has blood. And so on. So a lot of stuff comes from the bird class, and then above that comes from the animal class. And even above that, animals are objects. So you also know that a wug is an object in the world. Not all things are objects. Love is not an object. Computer code is arguably not an object. Some things have kind of more of an abstract reality to them, but we know that a wug is a thing in the world. That means it has a location, it has a mass, it has a length and a width and a height, and so on. So all these things are inherited. It helps us. It helps us as human beings make sense of the world. It helps us communicate with one another, because we can give so much information just in a single sentence by hooking in a concept that's new to a concept that we already know about. So here's how that might look in a UML type diagram. So a wug is a bird. A bird has a bunch of properties like this, and also has a beak. So since a bird has a beak, a wug also has a beak. So that association relationship also applies to the wug. And a bird's an animal, so it eats and moves around and sleeps and dies and so on. So the wug inherits all of this stuff. And notice the use of the open triangular arrowhead. This is not the same as the association arrowhead. So there's lots of different arrowheads and other markers on lines in the UML class diagram language. So you have to make sure you're using the right ones. This means association, this is has-a, and this means inheritance, and it's is-a. And in past, when I've taught this, I find that is-a is kind of a lot more natural and easy to understand than has-a, at least when it's implemented. Okay, so let's talk about inheritance in Java. So we can make use of inheritance to reduce code duplication. So it's a really useful code management tool, so that we don't have to keep reinventing the wheel over and over and over again. So let me first show you how it works, and then I'm going to show you the geometric object class, which is new this week. So let's go take a look here. So I'll create a class here. I'm just going to show you the mechanics of it. So we're not going to worry about what this class represents or what it means. I'm just going to create a new Java class, and I will call this superclass. So one of the things that we there's a lot of terminology around these concepts, and there's a lot of different words that mean the same thing. So this is going to be the class that we're going to inherit from. It's the class above in the inheritance hierarchy. So this is our superclass. We're going to create a private variable called a, which will be an integer. And yeah, let's just do add some code to it. So we'll insert real quick no. Let's not do it. Yeah, let's do a constructor. Should we do a constructor? No, let's not do a constructor. Let's do a equals 100. I'm going to leave constructors out of this for now. There's a section, not next section, but the one after, where we talk about constructors in more detail. I'm going to leave that out just for now. I'm just going to add getters and setters. So let's do a getter and a setter for a, just the default stuff. Okay, so because we have the superclass now, we have a private variable, defaults to 100, and we can access it like this. So this class doesn't do very much. It's just a wrapper for that variable. Let's create a main class. So with a main class and a main method, we can use superclass. We all know this already. Let's just call this object1. Object1. Call its default constructor, and then we can do stuff like this: system out println obj1.get a, obj1.set a 10, and then we can print it out again. There we go. So if I run this, we should just see 100 first for this one, and then 10 after I've set it to 10. Okay. Right, so far so easy. So then I go new Java class, and I'm going to make this one I'm going to call this one subclass. It's going to be the one that inherits. And all I'm going to do here is I'm just going to add, I'm not going to fill anything in, I'm just going to say that it extends superclass. So that implements the inheritance relationship. So in Java, we sometimes say that one class extends another class rather than inherits from another class. We say it extends. And because subclass extends superclass, any object that I create of type subclass automatically gets everything that's in superclass. So it gets all the variables, whether they're private or not. An object of type subclass will have a variable a, and we'll have these two methods that I can call on it. Okay, so what I can do over here now is, let's see, over in the main method, I can do the exact same code here, but let's call this obj2, and we're going to make it an object of type subclass, obj2 here. And you'll see that, lo and behold, you see there's no errors here. This code works on both objects, whether it's a superclass or whether it's an instance of superclass or an instance of subclass. So that's why one of the reasons why we say in Java that subclass extends superclass is because now we can add things to it. So let's do a private string variable called b equal to hello, and let's add a getter and a setter for that variable here. So now if I create an object of type superclass, it has one variable called a, and it has these two methods. Subclass has a variable called b, and these two set and get methods, and it also has on top of that all the stuff from superclass. So subclass has extended superclass. It's added a variable and a couple more methods. The code as I wrote it will still run just fine as is, but now I can also do this. I can go obj2.set b, goodbye, and system out println obj2.get b, like that. So now the object that's of type subclass also has this other variable and a few methods that go along with it. The superclass object, the extension doesn't go both ways. It doesn't extend, so I cannot do this. I can't go obj1.getB. There is no such method. So you see, cannot resolve method getB in superclass. So it does not extend subclass. Subclass extends it. So subclass gets its all of superclass's variables plus adds its own. Okay, if I wanted object 1 to have get b, I would need to move this method and the other stuff that I need. I have to move it up to the superclass. Okay, I think that's all that I wanted. Let's comment this out, but I'll leave it in. That's all I want to say about the mechanics of inheritance. It's quite simple. Now, I should also, there is actually one other thing I should say, which is that this variable here is private to the superclass. So I can't actually, like if I create a new method here, I can't actually access it. So I can't say system.out.println this.a. So you'll see we get an error there. A has private access in superclass. So even though a subclass object has that A variable, because it's private in superclass, I can't access it in the subclass. Now there are other types of access other than private and public that would allow this, but we're just not going to bother with them in this class. You can look them up yourself if you want. We're just going to keep things simple and stick to public and private. So I can't do I can't access A directly, but I can use a getter. So this dot get A, notice there's no get A here, so it's going to go up to the superclass and it's going to call the get A method from the superclass. So I can do it that way. Similarly, in the subclass here, if I create a toString, see it's not even giving me the option of A. If I wanted to add A, I would have to do something like this: A equals plus plus get A, like that, plus. There we go. Maybe we should do a little space there. Now we'll look at better ways to do this than what I'm doing here right now. But generally, I'm just trying to underscore the point that I don't have access to the A variable. I only have access to its getter. So the superclass remains encapsulated. So just to show this off, I can go system.out.println obj2, and we should get the toString that I just created with A equals 10 and B equal to goodbye. Okay. Now I want to show you some code from this week. So if you look in the week 8 code, this example here wasn't a very real example. It's just showing you the mechanics of how inheritance works. But here's what's cool about it. So if we look at, I've got some examples here. We've seen circle classes before, and we've seen rectangle classes before, and how to draw them. You can see there's 3 classes here called circle, draw, and rectangle before inheritance. So if let me look at the draw one first. If we run the draw method, it's made out of an FX graphics template, and it creates 2 objects. They have clunky names because of what I'm trying to show you here. Normally I would just call them circle and rectangle, but I have a different circle and rectangle that I want to show you as well. So I create 2 objects, a circle and a rectangle, and then I call draw on each of them. If we take a look at the circle class here, we should recognize pretty much what's in it. It's got a bunch of private variables for its radius, its location. It's got an outline color and a fill color, and it's got a line width. And then IntelliJ has folded up these things to make them easier for us to look at. But it's got getters and setters for just about everything: stroke color, Y, X, fill color, radius. Its set radius has a little bit of logic in it. It's got a get area, and it's got a draw method and a toString. Okay. Now, if we go take a look at the rectangle one, a rectangle is very similar to a circle, of course. Where is it? Here's circle. Here's rectangle. We need to make it a bit bigger. There we go. So here's rectangle. It's got a width and a height, which is unique to rectangles. X and Y, though, it also has, which it shares with circle. Stroke color, fill color, and line width are all the same. And then if you take a look at the code, get X, set X, get Y, set Y, these methods, we've seen them all before. They're all the exact same methods that we have over in circle before inheritance. In fact, let me just close all here and go back. If you do this and then switch between these 2 things, oh, there we go. you can see there's almost, the code doesn't even change. There is a ton, except for this line here, there's a ton of duplicated code. And if I page down here, let's see, there's probably even a little bit more. So down near the bottom is where things start to get a bit different. The get area and get perimeter methods for rectangle are different from the get area and get perimeter methods from circle. Circle has a set radius and a get radius, whereas it's get width, get height, set height for rectangle. And the draw method's a little bit different. But there's a ton of stuff that is duplicated between these objects. And so if you think about it in terms of the ISA relationship, all this stuff that's duplicated, like their color, their line width, their location, these are sort of generic things. So you might say that, you know, circles and rectangles are both shapes. So there's a bunch of stuff that we can know about a circle and a rectangle just knowing that it's a shape, like it has a position, it has a size, and so on. So exactly what ends up going in that superclass, in that class that you're going to inherit from, totally depends on what you want to do with it. But the general idea here is that we're going to create a geometric object class that contains all of the stuff that is common between circle and rectangle. So you see the X and the Y, stroke color, fill color, line width, get X, set X, all these getters. You can see, again, switching between rectangle and geometric object, they're the same. So what we can do is, now that we've got all this generic stuff, which is to do with the colors and the positions, in its own class, now we can create a much better version of circle and rectangle. So if you go to just the circle class here, it just extends geometric object, which means it gets all of this stuff, and then it can add the special stuff that it needs to make it a circle, right? So a circle is a geometric object, which in our implementation means it has an X and a Y, and these three instance variables that relate to how we draw it, its colors and its line width. But then because it's a circle, it also needs a radius with a getter and a setter. It's got a get area method, and it needs its own draw method so that it can draw itself on the screen. Similarly, if we look at rectangle, the new rectangle now also extends geometric objects, so it gets all that stuff, and then it just adds the stuff that's specific to rectangles. So this is a really powerful idea in object-oriented programming. You don't have to, if you have different kinds of objects that are basically the same but have slightly different properties, you don't have to reinvent the wheel over and over and over again. So if we had decided, for example, that X and Y should be integers and not doubles, we're going to have to change without using inheritance, we have to change every single object class, every single object class that's a shape object. So we might have a rectangle, a triangle, a polygon, a circle. We might even have three-dimensional objects like spheres and so on. We have to go through them all and change all of these to integer. And that's a big code maintenance issue. It introduces the possibility of bugs if we don't do it the same way in every object. But in this other implementation, if we decide that these are now going to be integers, all we have to do is change one class, just the geometric object class, make sure that it still works just fine, and then the circle and rectangle classes will just inherit all that stuff, and everything should work out just fine. Okay, so that's the idea behind it, and there's a draw method here that uses just the new circle and rectangle classes. I think I have to do an extra set X, because when I inherit from geometric object, I can only pick one default value for X and Y, whereas you might have noticed the circle before inheritance had one default value and the rectangle had different default values. So to make this work, I have to do just a slight bit of extra work in the draw method to move the rectangle away from its default location, and then I just draw them. So other than that, it looks the same as draw before inheritance. The class names are different, but it's just create them, draw them, and print them out. And then this draw method here, create them, move one of them over a little bit, and then draw them. And so it looks like this. Okay, so the result is the same. Again, and I've said this before, in object-oriented programming and in this course, making it work is not good enough. It has to be beautiful. The code has to be beautiful, has to be elegant and make use of the properties. Sorry, I can't talk today. It has to be elegant and make use of the principles of object-oriented design. And that's what the new version of the circle and rectangle thing has as an advantage over the old one. So the before inheritance one had tons of duplicated code. This one is much nicer. It's using inheritance effectively. So if we now go over to here, this is how we would draw this situation. So the geometric object has these instance variables and the getters and setters that are associated with it. It also has its own toString. And then the circle object and the rectangle object add the stuff that they need to get the job done. And their draw methods, for example, if we go back and look at their draw methods will make use of the getters and setters that are defined in geometric object. So when I call getX from here, I can call it as if it was defined inside the circle object. It will, because I've inherited it from geometric object. So I'm calling the geometric object getX here. Okay, so this is it's purely about code organization and just making your organization nice and make sense. So there's a bunch of terminology here. We've got circle is a geometric object, rectangle is a geometric object. We also say the circle extends geometric object. We sometimes say that the circle is a child class or a subclass, and the geometric object is the parent or superclass, or sometimes we say the base class, because this is the base class that's going to be extended by circle, or it's the superclass and the subclass extends it. These are all different ways of talking about the same thing, and you'll see people kind of move back and forth between them, which is why I have to be confusing and introduce all of them. Otherwise, you're not going to be able to understand the things that you read out there. So the circle object contains all the methods and fields, instance variables in the circle, and in the geometric object class. So when I create a circle object, I don't just get this stuff, I also get all this stuff as well. Okay, but you do have to worry about access. I don't have direct access to X, Y, stroke color. I have to use getters and setters and other methods to interact, just like I would if I was outside of that class. And yeah, you might notice here there's a toString here, and also there's a toString here. What's happening here is what's called overriding. So it's the circle method, toString method is overriding the one from the superclass, but that's the topic of the next section in the next video. Okay, and oh yeah, and one last little note, why don't we have constructors? Because constructors are more complicated, so we're going to deal with them in a later section. So the next two sections are going to be overriding, to talk about what's going on with toString here, and then constructors, to show how inheritance works when you have constructors in there. Okay, I can also show you, by the way, if we go back to last week, the week 7 guide, just to remind you, at the very end of the guide is this little diagram that shows you, and I just did it this way to keep it simple, like buttons and labels and text fields have these have constructors all their own, and button has a set on action method to set a handler, but all three of them inherit from these superclasses. There are actually 3 superclasses they inherit from that I've summarized here that contain these like get text and set text and so on. And all of that inherits from Node, which has the relocate method and the set style method and the request focus method that's inherited by all of these things. So we did get a sneak preview last week when we saw this. And one last thing I'll leave you with. If we go Java FX API, I guess 15. Yep, right here. Let's go look at one of these classes, like Node, for example, right here. Oh wait, that's not a good example. Let's do label. That's a better example. So what you're seeing up here, you see, okay, up at the very top, class label, and you know that what's down here is a description of the class, and then you get constructors, you get properties, fields, methods, and so on. It's also showing you, where are we? Right here, methods inherited from other classes. So the label object, when you use it in your graphical user interface, natively only contains these methods, but it inherits, set text, for example. Let me find that. There you go. It gets inherited from this class called labeled. And it inherits things like tooltip property from the class control and so on. So there's a whole pile of stuff in label that it's, oh my goodness, look at all that it's inherited from these other classes. And the inheritance hierarchy is here. Label inherits from labeled, which inherits from control, which inherits from region, parent, node, and eventually from the top level object, which is object, which we'll talk about in a future lesson as well. So more and more we're learning as we understand these object-oriented concepts. I think you guys are more and more equipped to understand what the Java and JavaFX API documentation is telling you. All right. So what I would like you guys to do now is, here we are. This is the exercise document. These exercises just ask you to add a few things to the circle and rectangle classes. So what I want you to do, number one, is identify circle and rectangle draw method. There are some lines of duplicated code. So I want you to create a method in geometric object to do that job, whatever lines there are duplicated, and then call that method from circle and rectangle. You can make it private. No, you can't make it private. So it's like a helper method. And then I want you to create a whole new class called square. Use inheritance effectively. Okay, so it has to extend something. Make sure you have a get area, get perimeter, and draw, and then target. And this one should inherit from circle. So this one should extend circle, and then implement its own draw method so that it draws another circle outline with a half radius like this. Okay, and then I do want you to try and do a UML diagram of the whole set of 5 classes. So that's circle, rectangle, square, target, and draw. No, not and draw. Circle, rectangle, and geometric object. And geometric object is the 5th one. What your thing should look like when you run it is, let's take a look here. I think here it is right here. So there's solution code given for you here, but this is the idea, is that a square is like a rectangle, but it only has a size. It doesn't have a length and a width. It's kind of more like a circle in that way. And this one here is inheriting from circle. So you can go take a look at that sample code when you're done. But I'd like you to try those exercises and then come back for the next video, which will be, I think, quite a bit shorter and is on overriding. All right. Good luck.